Next, we are looking at the direction of the magnetic field produced by a straight conductor. So one thing is it is circular, right? Concentric circles. So is it clockwise or anti-clockwise is the question that we're trying to figure out. So that can be answered with the help of something called as right hand thumb rule. So the rule is quite simple. I'll explain first, then we'll read the statement. So given a wire, if I know the direction of the current, right? In this case, in this particular experiment, the direction of current is downward. Say I have set up in a way wherein the current is going upward. I should try to hold the wire with my right hand such that the thumb is pointing in the direction of the current. So basically in this way. So how are the fingers wrapping it? If you look from top, right? If you view from this point, so that's supposed to be a camera. Okay, so if you view from here, so clearly this is anti-clockwise, right? In this case, the current say it's going downward. I should wrap my hand such that my thumb is pointing in the direction of the current. That is again downward. So my fingers are wrapping the wire, the other fingers that is. Again, if I view from top, this is supposed to be what? Clockwise. Okay. This is anti-clockwise and this is clockwise. That's it. Very simple. So in this case, the direction of the current is clockwise. Okay. So you have to use your right hand for all the cases, first thing. And thumb has to be in the direction of the current and the other fingers will give the direction of the magnetic field. Right. So now let's read the statement and check what they exactly tell. The direction of the magnetic field is perpendicular to the wire. This is very important. This I am not told. See, here I told that we have to place a cardboard. So should it be tilted or how is it? No. It should make an angle of 90 degree. Okay, this plane should make an angle of 90 degree with the wire. So the circles are always perpendicular to the wire. Okay, make sense? So in this case, the cardboard should be in this way, making an angle of 90 degree. Right? So here, the magnetic field will be in this way. Supposed to be, I mean, the influence is higher over here. The next thing is, next part of the statement is this. This is the second part. And the magnetic field is in the direction of the fingers of your right hand would curve if you wrap them around the wire with your thumb in the direction of the current. Okay, so this is your second point, and that's what I explained. So this fancy statement is just telling this. So the condition is direction of thumb and direction of current has to be same. Right. So to confirm our understanding, we'll go back to the videos which we watched. So one thing which we have to make a notice, the perpendicular surface. So in this experiment, right, in this particular setup, I have the surface to be perpendicular. Okay, one thing. But here it is not so. So, but yes, deflection and influence and all will happen. But yeah, deflection is not to that extent strong. So that's the reason over here. But anyways, the question over here is, what is the direction of the current? I have given the deflection, which you can see already. And here too, the deflection is shown, but I'm not written over there. But yeah, I'll explain that. So the deflection is seen over here, right? In the perpendicular surface, the deflection is seen to the left and to the right. So there are two different cases. The answer should be either up or down, right? So watch the video again, right? Have a look and come to your conclusion. So what is that we are looking at? In this case, since the wire is being wrapped in clockwise direction, right? Because the deflection is anti-clockwise direction, the thumb by default will point towards the sky, that is up, right? Whenever they give you deflection and ask to find the current, all you have to do is try to figure out in both the ways. Try to hold the wire in both the ways and be sure of the wrapping and the deflection is the same. And whatever the thumb is, that will give the direction of the current. So in this case, if you think about it, it is pointing downward, right? So in case one of next set of video. So here too, you guys can have a look at the video and make your conclusion. So first thing first, here the deflection happens to be towards the, okay, away from us. And here it happened to be towards us, right? Now, how should you hold your fingers? See, one of the things which I advise my student is this. Try to wrap your finger such a way that the fingers, the four fingers, right? It's not bent. It's bent from your knuckle. Your hand is bent from your knuckle, but not after that. Your fingers are straight. Don't try to wrap it. Why this helps is, it kind of gives you a definite answer, right? If you wrap it, I've seen it's confusing. It's confusing for me also, to be frank. But if I do this 90-degree wala scenario, right? So this is making an angle of 90 degree. That is, the fingers and your palm is making an angle of 90 degree. So try to hold it that way. So your thumb will point in the direction of the current. So it is towards the left. Okay. So in this case, right, it makes sense, right? Deflection was away from us. So the fingers have to be away from us. And the thumb by default, right hand thumb, will be pointing towards the left. And in this case, our hand kind of goes below, I mean, right? So that the fingers are on the top. See, why the fingers have to be on the top always is because the compass is on the top. Okay, wherever the compass is, that's where your fingers have to be. So that's the advantage of wrapping it half the way. So the fingers have to be this way, only then it will wrap properly. Make sense? Right? Let me draw it properly. That is your thumb pointing towards the right. That's your palm. And yeah. Okay, can you imagine this? Again, it's important for us to understand that you have to look at where the compass is. So the compass is up on the, it's not on the, it's on the wire, not below the wire, one thing. So your fingers have to be, imagine that they are on the wire, not below the wire. In this case, your fingers again have to be on the wire. For that, my palm is below the wire. So in that case, my thumb will be pointing towards the right. I'll try to make a separate video on this, but I hope you guys understand. So to conclude, we are looking at magnetic field produced by a straight wire. So one thing is the structure is concentric. That is concentric circles with center as the wire. Center as wire. Okay. And to talk about the direction, if it's clockwise or anti-clockwise, we have to make use of right hand thumb rule. Very straightforward. Try to wrap it half the way. Don't do it. Here the diagram also shows that only. So I bend it from my knuckle. Okay. So this is perpendicular to this. It helps. So try to wrap your trap the wire in such a way that the thumb points in the direction of the current, and your other fingers and everything will give you the direction of the current. Sorry, not current, sorry, magnetic field. As simple as that. So you can pause and write all of this. And over here, try to make your own running note and try to see to that you understand this better. It's not too hard, but again, if you miss it, it should not be missed. It's quite simple. So please make a note on the trick as well. What trick we have to use to get the answer. Folding your hand half the way with palm and the hand being perpendicular to each other. So one more important point that I have to mention is the magnetic field lines are perpendicular to the wire. So here we can see a lot of deflection. Here I had connected a resistor also, I guess, if I remember right, in this experiment. I actually don't remember to that extent. I think I did connect. One thing. Second thing is it's not perpendicular. So because of these two reasons, the compass didn't deflect to that extent. So that is something which I missed over here because again, the setup is not convenient. If you have the 360-degree wala compass, then it would make sense. Anyways, so please make a note on whatever you understand over here. It's important.